They helped out with the track meet on Tuesday, May 3rd. Okay, so here's what we need. I will not be in class tomorrow. Okay, I will be gone at a track meet. And then on Wednesday, that's the AP Bio exam. Is it in the morning or afternoon? Afternoon. It is in the afternoon. So I won't see some of you then, will I? So what will happen is between today, tomorrow, and Wednesday, we will only cover the topic polar coordinates. That's it. But what will happen is I will record the little bit that we don't get to today. I'll record that tomorrow when I teach third hour. And then you guys can watch it and try to get through the rest of it. I will. So, we all good? So, let's begin. I venture to guess we will only get through 2 topics. Just 2 topics. Basically 3 lessons before seniors will have to leave. Okay? You have 4 or 5 topics in your notes. We won't get to most of them. We won't. I just didn't know how many days we would have. I needed to check to see where you guys were at with AP testing and everything like that. So here we go. It says we are looking at polar coordinates. There's different kind of coordinates out there. There's XY coordinates, and then there's other coordinates, R, theta. And that's what we want to look at today. These have a tie into trigonometry. The good thing is you know how to do a lot of it. Actually, plotting the coordinates is sometimes the most challenging part for people. So let's figure out how to work through this. We would like to plot the coordinate 3 pi over 4, and then we will rename it later on. Okay? And what's different about plotting polar coordinates is we have an angle and we have a radius. And instead of plotting x and then y, I would encourage you to start with theta and then go to r. So theta is pi over 4, so I'm going to rotate pi over 4, which brings me to right there. And then the 3 means I'm going to move 3 units in that direction. So 1, 2, 3. Is everybody okay with that plot? I turn pi over 4, and in the direction of pi over 4, I go 3 units. Simple enough? Let's try another one. It says plot the coordinates 1, 3 pi over 4, 3, negative pi over 6, negative 3, negative 3 pi, and negative 4 pi over 4. So we're going to do those 4 right now. We're going to start right here with 1, 3 pi over 4. So don't think about the 1. First focus on the 3 pi over 4. That brings me right there. And I go 1 unit in that direction. So that's that coordinate.
Wait, so the one that you did before, you went 3 from
the center?
Yeah. Oh, it's from the center?
Yeah.
Wait, so then the one that you did before would be like... Oh.
All right, here we have 3, negative pi over 6. How many degrees is pi over 6? 30 degrees, because it's negative pi over 6. Negative 30 degrees will be down at 330, as Patrick says. So I'm going to rotate to right there. And then the 3 means I move 3 units in that direction. Notice the next one says negative 3, negative 3 pi. What's different about this is that the radius is negative, isn't it? First, I'm going to rotate negative 3 pi. I have negative 1 pi, negative 2 pi, negative 3 pi. So everybody agree that negative 3 pi brings me to about 180 degrees. The negative 3 means instead of moving 3 units in this direction, I move 3 units in the opposite direction. 3 units in the opposite direction. You go away from the angle of rotation. And then I have negative 4 pi over 4. So I'll rotate pi over 4, which is just 45 degrees. And then from that rotation of 45 degrees, I don't go 4 units in that direction. I go 4 units in the opposite direction. Not too bad? There's other ways of describing these points. As you notice, 3 pi over 4, that's one way to describe it. I'm going to describe it another way. So I have 3 pi over 4. And I'm going to get to that same location, but I'm not going to travel pi over 4 units. Instead, I'm going to travel this direction. Can somebody tell me what kind of angle brings me to that location? It's -7 pi over 4. Yep. If you think about it, all the way around the circle is 2 pi, or 8 pi over 4. So if this was 1 pi over 4, that means we go 7 pi over 4 in the opposite direction. So that location is 3 and -7 pi over 4. There's another coordinate that could get me to the exact same location. Instead of going to this spot, I am going to go to the spot that is exactly opposite from it. What angle of rotation is that? Yep, 5 pi over 4. 225 degrees, or 5 pi over 4. So, notice that if I traveled 3 units, I'll be 1, 2, 3. I'll be right there. So what do I do if I want to travel in the opposite direction? Yeah, so a -3 would bring me 1, 2, 3. So -3, 5 pi over 4 would bring me in that opposite direction. Okay, then we have one more. Suppose I want to get to that same spot. I rotate in the opposite direction. What is -3 pi over 4? And instead of traveling 3 units, 1, 2, 3, I'm going to travel 3 units in the opposite direction in order to get there. So you can see that for each coordinate, there's many ways of representing it. And then you can obviously travel more than once around the circle as well. So there's an infinite number of ways of expressing that exact same point. So what I would like you guys to do is I'll do 2 of these with you, and then I'd like you to do 2 on your own. I'd like you to rename this with a negative radius, and then positive radius, positive radius. I'll do number 1 and 3 with you. You'll do 2 and 4 on your own.
Okay.
A negative radius. Tell me, where should I rotate in order to get a negative radius for this one? Can we go like this? Okay, so to that spot, how much is that?
Negative.
That's -pi over 4, so that would bring me to this location. And then instead of going 1 unit, I'm going to go -1. Good. Let's look at number 3. It's given a negative radius. I'd like a positive radius. Isn't that just 3, 0? Zero means a rotation of 0, and then 3 units that way. Yep. You try number 2 and 4 on your own. Go ahead, see what you can come up with. So I have -3 and 5 pi over 6 for this one. So if I rotate 5 pi over 6, that'll bring me to this spot. Instead of going 3 units, I go -3 units. Is that okay? And then the last one, I'm going to rotate 5 pi over 4. And I'm going to go 4 units in that direction. Any questions? Okay. For this test, you put together your own notes again. You will put together your own notes.
Wait, what did we do for the last one? Are we letting
4, 5 pi over 4. What's that? I'm sorry. No examples. All right. Sure. All right. So we would like to be able to convert back and forth between these. So we would like to be able to go from polar, which is r theta, and convert that to xy. We would also like to be able to go from xy and convert it to r theta. I would encourage you to include something like this on your notes. I think that this would be the most important part. So if I have a coordinate that's plotted, it has a radius and it has an angle. But it also has an x value for location horizontally, and it has a y value for location vertically. Does that drawing look familiar to you? I hope it does. We've seen it before multiple times, which means that what we're going to see is actually a review. Converting rectangular to polar. So given x and y, I have to come up with r and theta. Can somebody tell me, if you were given x and y, how do I come up with r? Good. So r is the square root of x squared plus y squared. And that should look familiar to you. Yep, exactly. And then if we're given x and y, how do we come up with theta? Tangent of theta is equal to opposite over adjacent, so y over x. So have you used those types of formulas before? And so you're going to continue to use them again. Let's look at the other side of things. Suppose we're given r and theta, we want to come up with x and y. Can somebody think of a trig expression that involves x, r, and theta? Cosine of theta is equal to the adjacent, which is x, divided by the hypotenuse, which is r. If I want to solve for x, I multiply both sides by r, and I get r cosine of theta is equal to x. Anybody want to guess what I do to get y? R sine of theta is equal to y. And so those are the conversions that we use in order to convert back and forth between polar and rectangular and polar. So the first thing you're going to be asked to do on your test is you're going to be asked to plot points. After you're asked to plot points, we'll be then converting between them. That's what we want to make sure you're able to do. So let's try the first one. It says convert 4 2 pi over 3 to rectangular form. That means I want to start with polar and I want to go to rectangular. So I'm going to use these right here. So this is r and this is theta. I want to come up with x and y. Well, no big deal. It says that x is equal to r times the cosine of theta. What is r in this problem? 4 times the cosine of 2 pi over 3. And then y is going to be 4 times the sine of 2 pi over 3. Do we know what the exact value of sine and cosine are for 2 pi over 3? Yes, we do. As you look at this right here, 120 degrees places us right there. What is that coordinate? Negative 1/2 and root of 3 over 2. Is cosine the x value or the y value? It is the x value. So we have x is equal to 4 times negative 1/2. And y is equal to 4 times the root of 3 over 2. Notice what's going to happen. Half of 4 is 2. I get negative 2 for the x value. And then for the y value, 4 divided by 2 gives me 2. I get 2 roots of 3. That is the rectangular coordinate for that polar coordinate. Go ahead, please try the next one on your own. Try the next one on your own. Go. Should have x is negative 2 cosine of 5 pi over 4 and y is negative 2 sine of 5 pi over 4. 5 pi over 4, anybody know what the terminal point there is? Yep, negative root of 2 over 2, negative root of 2 over 2. And so we get negative 2 times the negative root of 2 over 2. And we get negative 2 times negative root of 2 over 2. So it looks like they are the same. Notice that the negatives will cancel and the 2's will cancel. I get the root of 2, the root of 2. Now, I don't know about you guys, but I don't like getting problems wrong on the test. So I'd like to find a way to check to see if my answers are reasonable. And as I look at this, I notice that the root of 2 and root of 2, that's in the first quadrant, isn't it? Well, let's look at our original coordinate. It has a negative radius and has 5 pi over 4. Let's see if that brings us to the first quadrant. 5 pi over 4 rotates all the way over here. And if I go negative 2 instead of going this direction, I go 2 units in the opposite direction. So that does place me in the first quadrant. So there's all sorts of ways to check and verify to see if your answer is reasonable or not. Do our last example for the day, which is example 3. And now it says find the polar coordinates. So I'm currently given x, y, and I want r theta. Well, fortunately, I know that r is equal to the square root of what? Very good. 3 squared is 9, and negative 3 squared is also 9. And so I get square root of 18. Can somebody simplify the square root of 18 for me? 3 roots of 2. And then I would like to come up with theta. So I say tangent of theta is equal to? Negative 1. Tangent is negative in which quadrants? 2 and 4. Which quadrant is this in? Is this in the second quadrant or the fourth quadrant? As you look at it, this is the fourth quadrant because I go over 3 and down 3. So that's the fourth quadrant. If you inverse 1 on your calculator, what do you get for tangent? You do get 45 degrees. So if that's a 45-degree angle, then what is this angle in the fourth quadrant? 315 as we subtract from 360. What is 315 degrees in radians? 7 pi over 4. So theta is equal to 7 pi over 4. Have we done this before? We did it with complex numbers. We did it with vectors. And now we're doing it again. This is the third time you've seen it. Hopefully we can get them right. So the coordinate is 3 roots of 2 and 7 pi over 4. That is my polar coordinate. Please try the next one, negative 5 roots of 3 and 5 on your own. We'll check to see if you have it correct. Go ahead. So I have the square root of 75 plus 25. I've got 10 for a radius. Anybody else? Then let's talk about the angle. This is where we struggled during the course of third hour. I have the tangent of theta is equal to the b value divided by the a value. And you see that those cancel, and I get negative 1 over the root of 3. Sure, you could write it as negative root of 3 over 3, but it's not your final answer, so you could just leave it like that if you want. Is that an angle? It is definitely not an angle, is it? Where is tangent negative? 2 and 4. Which quadrant is this in? Second quadrant. If I inverse 1 over the root of 3 for tangent on my calculator, what do you come up with? 30 degrees. So if that's 30 degrees, what is that angle? 150 degrees, otherwise known as 5 pi over 6. So I have 10, 5 pi over 6. That's my angle. Now, something that you may not realize is that your calculator, if I turn it on, if I press mode, I actually have, if you look here, I have function mode, which is rectangular coordinates, x and y, but you also have polar operations. If you notice, if I press y equals, I come up with r values. In fact, I could go 5 theta here if you want. And I don't know, let's just check out the graph, see what we get. Get all sorts of shapes. Yeah. So there is a great application for these things, especially when we get into curvature, motion, dynamics, physics. We'll just investigate a little bit. So I'll have a video ready for you to watch tomorrow. You will have a substitute, and please give them your best behavior. Yes.